Hello everyone, let's start with our 13th question, which have two parts A and B. First one, A. Draw the equipotential surfaces corresponding to uniform electric field in the Z direction. Okay. First we understand the equipotential surfaces. The equipotential surfaces are the equidistant plane perpendicular to the Z axis and does not draw them, or the equipotential surfaces are equidistant plane. I will mark for you. The equipotential surfaces are equidistant parallel to the plane, and this is the diagram of equidistant surfaces. These are equidistant from each other. These are planes which are equidistant from each other. Now come to the second part. Derive an expression for the electric potential at any point along the axial line of an electric dipole. Let us consider a line which have charge minus q to plus q and the center O. The distance between A to O is O and O to B is O. Now let's find the potential at point P. At point P, at positive side. Vp equals to V minus Q plus V plus Q. Net potential. So the Vp equals to 1 by 4 pi epsilon naught, 1 by 4 pi epsilon naught minus Q by R plus A, plus 1 by 4 pi epsilon naught Q R minus A. Taking Q by 4 pi epsilon naught common, we will get 1 upon 1 R minus A minus 1 upon R plus A. By further solving it, we will get Q into 2A upon 4 pi epsilon naught R minus A square. Hence, P is the dipole of the moment, so put Q into 2 by A as P.